Sorry, but how do we do this? Just we do here by ourselves.
How do you,
Do this one you're showing now.
yeah, check
There's
me.
a quiz handout in the website that you download.
But yeah, this is the one we have to upload until tomorrow. By tomorrow,
No, this is
or
the
have to up.
quiz. This is the quiz he's showing you. There's a download on the website that you can download the quiz, and it'll have the answer that you can write down.
Right now and upload now.
No, I don't think you need to upload right now. I think you said you still have tomorrow to upload it.
Exactly.
Hey, Mr. Pham, while they're doing that, just so you know, on D Lab 1, where you put your name in, you when you click on that box, you can't put your name in. And also, there look like there's some other problems, but I'm just saying when you get a chance to look at D Lab 1.
Okay.
Recording in progress.
Okay. Any questions? Oh, man. Any question about the quiz?
I have a question.
Yeah.
So the last question is from the lab volts section, DC power sources, which comes from before Ohm's law. But you guys told us not to do any of the sections before Ohm's law in lab volts.
Okay, that's just a very, very basic on the DC.
Yeah, but if we don't have an opportunity to learn series opposing, then how are people going to get that question right if you don't allow us to learn it?
Okay, that's coming out from the DC fundamental, not the left volt on the lecture.
Really? Can you show us in the handout where series opposing can be found?
Okay, whatever.
Yeah.
The thing is that Ohm's law is voltage, current, and resistance. And if you have two of those factors, you can figure out the unknown.
That's just telling you. The DC voltage, they can be connected in series or in parallel. Then you have to know how to calculate that.
Yeah, the example was series opposing though. Just saying, you haven't provided that information, yet you're asking the question.
For parallel, that's the same. Okay. Let's see. That's okay. You see, I got a very hard time to fix the iPad. However, now we get the problem.
Professor, you're getting feedback. You got another
Yeah,
microphone on.
that's what I just get the feedback, not before. But after I correct the pointer, everything looked like okay. And now you get a problem with the feedback. But anyway, can you hear?
We can hear, but it's just echoing a lot. You
Okay.
sure you don't have a microphone on your monitor or something?
No, we don't have any microphone here. Just I already on the iPad.
Hey, John, mute your mic.
Yeah?
I
No,
think you're causing the feedback.
no, I did not. I got to go library or I go from different computer and got it information all.
Okay.
Yeah,
Anyway,
he's just asking you to mute yourself.
Oh,
see.
The little speaker icon, John.
Let's see how the professor sounds now.
Your guy talking, no feedback. But when I talking, it's feedback.
Yeah. There's another microphone open someplace feeding back from the speakers.
I get on the iPad and my computer. And iPad I already
No cell phone, maybe.
Yeah, that type of echo only comes from a feedback between two microphones and a speaker.
Okay, let me, I turn off my cell phone to see what happened. Okay, still same, right?
Oh, it's even worse now.
Okay, I will find out, okay?
Okay, hey.
Okay, today, I was talking about bipolar transistor. And this will be DC. You get two parts. One will be a DC. And the second one will be amplifier.
Professor, we didn't understand, I at least didn't understand a single thing you said because of all the echoing and feedback.
Let's see.
Mm-hmm.
Am I the only one, or are there other people hearing that echoing?
I can also hear the echo.
Yeah, I hear it's really quite bad.
Me too. Ooh.
Okay, anyway. Now we're talking about transistor. Okay, you get two different type transistor. That will be NPN, and that will be a PNP. If you're looking into it, how can we recognize NPN or PNP?
The arrow is either facing the base or opposing it.
You're looking into here. The arrow. Okay? NPN is going out. PNP coming in. Okay? And the one here we call a base. And they get a current IB coming in. Collector here. Current IC going in. At meter, i.e. leaving. And on the PNP will be opposite. IB leaving, IC leaving, IE coming in. Basically, IE equal IC plus IB. Okay? And also we want to know the beta. That means the gain equal IC divided to IB.
This sounds so bad.
So do those equations fit for both types of transistors?
Yeah. Two type, right?
Right.
One we call NPN and one we call PNP. Now, this is the basis for the physical. Okay. First thing we're talking about NPN. That means you get an N side. Okay. And that will be a P side. So that's why you get the NPN. This is the base right here. Okay. And collector, okay, they can get a current coming in. That meter, okay, leaving. And the other one here, PNP, P side and N side in the middle here. So basically you get two diodes, PN one diode, PN another diode. Okay, so that's why basically this is the NPN here, and you can see two diodes. First thing telling me, one will be from the base to the emitter. Another one from the base to the collector. Okay, and on this PNP, same thing. Okay, you can get two diodes. PN, that one diode. PN, that means another one diode. Okay, when another section of P or N type material is added to PN diode junction. A 3-section device contains two junctions in the front. Now you can see in here from the NPN, from the base you get one diode to collector and one diode to emitter. Okay, and PNP same thing. You get a one diode, okay, from collector to the base and emitter to the base. And this is a symbol, okay, for NPN. And this is a symbol for PNP. This is the IC and you're working on. Okay, so basically, transistor they combine two diodes. Okay,
Can you repeat what that thing is on the extreme left? What is that called again?
can you repeat it again?
Can you tell me what the item is of the picture of the component on the left side of the screen?
Left side here.
Yes.
Okay, basically that's a real MPN. When you're working on the left volt, you can see this IC. Okay, and one will be emitter, in the middle will be base. Number
You said it's an IC, Professor. You say it's an IC.
what the problem?
You might need to reduce your volume there, Isidro.
Okay,
It's a transistor. That's what the transistor actually look like.
I think he said it was an IC.
yeah, that's just a, in general, just a transistor. Just a minute. I want to reduce the volume.
Hey, Mr. Pham, you know what I was thinking? Maybe if you click on your microphone and shut it off for a minute and turn it back on, and maybe that'll clear up the feedback.
Okay.
Or maybe he has two Zooms running at the same time on the iPad or something.
But anyway, I have to spend more time to working with that problem. Okay. So we try to see if we can get through it, but not at this time. Okay. Now you see that the circuitry for NPN and PNP. This is a transistor NPN. Okay. And basically, you can see this is a base. This is a collector. And that will be admitter. Okay. So you can see how the current flowing. You get the first one, VBB. The second power supply, VCC. Okay. You can see the difference. PNP, this is a negative. NPN, this is a positive. Okay. And also VCC, positive here. However, for PNP, opposite. So now, from the base to the emitter, what the voltage? You know, this is just a diode. So the what voltage here?
I can't see where you're asking what voltage.
I'm asking about from the base.
He's saying it's 0.7. So the
Oh,
transistor,
here.
Okay, gotcha.
transistor consists of two diodes, so it's
That's just a short
0.7.
diode. So the voltage will be 0.7. Okay, if you want to doing calculation, I show you. You draw the loop for the current. Current I. First thing when they hit into the negative VBB, then you get minus V B B. Then when they go into the RB, positive here, negative on the other side. So you have to plus VRB. And then you hit into VBE. That means you plus 0 point equal 0. So from this equation, VBB you're supposed to know. VRB, what VRB?
It's IBRB.
VRB, IB, time RB. IB. So from this equation, you can see, you can get IB, RB equal VBB. Minus 0.7. This will be helping you to calculate the IB. VBB minus 0.7 divide. Okay, so this is the equation you need to know. IB equal VBB minus 0.7 divide RB. Now, if you get IB, and you can calculate the IC. What IC equal? This is right here. Let's see. IE equal IC plus IB. Okay. And also, you know this formula. Beta equal IC divide IB. So IC equal beta and IB. Okay, and in general, IE, IC plus IB. You already know IC and IB. You can calculate the IE. They will be, formula will be the same thing for both. Now in here, they already given you everything. This is a circuitry. You get VCC, NPF, and VBB. If you want to calculate the IB, IB equal VBB minus VBE divide RB. VB to E, that will be 0.7 volt. Okay, so you want to do a calculation on of the formula here will be helping you here or here. Okay, and here. And that's what you need to look into that. However, if you want to know the value, you can run the MSIM saver. Okay, they can give you any value you want. The thing right now, we want you to try to understand. First thing, you're looking into the transistor, you know, NPN or PNP. Second case, if the NPN, then the voltage from the base to the ammeter, 0.7. for silicon diode. Okay, so now on this one, can you do
Hey, Mr.
quickly
Pham,
calculation?
Mr. Pham,
Yeah,
you just, if you go back to that other screen just a second. Okay,
Yeah.
right there. Yeah, at the bottom right in red, where you got IB equal IE divided by parentheses 1 plus beta. Can you go over that real quick?
you're talking about that one,
At,
right?
yeah, at the bottom though, where it says IB equal
Okay, I know. Now, I tell you. First thing you know, IE, IB, plus IC, correct? And if you want to calculate IB, IE minus IC. Okay?
right.
Or you want to calculate IC, IE minus IB. However, IB will be very, very small. So that's why they don't like this formula. They want to find different ways. Okay? So we know IC equal beta times IB. What is the beta?
The beta
Beta
is
is
the beta is, no, go ahead.
Oh,
okay? So now, if you want to calculate the IE, will be equal IB plus IC. IC I don't want. I want beta times IB. And that also equal IB. 1 plus beta. That will be IE. Okay, IE here. This is the formula right here. Instead, you using IE equal IB plus IC. They don't want that. Okay, you can better using this formula. Okay,
And then the one on the bottom is IB.
right. Then, if you want to calculate the IB, okay, let's see. IB equal IE minus IC. They will be IE. minus IC. Okay. Basically, IC equal beta times IB. Okay. And now you can see IB love beta IB. Equal IE. Okay, so that will be telling you IE equal IB times 1 plus beta. Okay, and if you want IB, you can get same thing. IB can be equal IE divide 1 plus beta. That's what you get right here.
So basically, when we doing these calculations for the transistor, you want us to use the formulas in the red blocks, right?
Exactly.
Okay, got it.
Better than this one.
Yeah.
Okay, quickly. Number A, what B equal? They say they want IB, IC, IE, VBE, VB, VE, VC, VCE. And they given you beta at 150.
VBE is 0.7. You gave it to us,
Yeah.
where it says no.
Beta 150. That will be 0.7.
7.
And now they want to know the current IB here. Okay? And basically, I told you, you draw the loop current IB. Then you can get minus 5 volts. And when you hit into RB, you can plug IB.
RB.
RB. And that will be plug minus 0.7. Equal 0. So IB times RB equal 5 minus 0. Equal 4.3 volts. And that will be given to you. IB equal 4.3 divide RB 10K. Okay, 4.3 divide 10. Okay. Want to divide to kilo ohm, you get a milliamp, 0.43. And now they want IC. beta times IB. Beta 150. $64.5. IE using this formula. 1 plus beta IB. That means 151 times, okay, 0.43. 64.9. VB. Okay, you want VB. IB. RB. And that you get 0.43. Milliamp. RB can take. $4.3 volts. VE. What VE equals? When you're looking through the circuitry, telling me what VE. This will be VE. This will be VC.
So it's VCC minus,
I'm talking about VE.
right.
What VE equals?
Oh, VE is, that's the voltage from emitter to ground. So is that 0?
Yeah,
Because there's no resistor there.
exactly. And now you want VC. Right here. Okay. Basically VC. This is a VCC. Okay, we want to know how much voltage drop across our C. So they will be equal
ICRC.
minus IC. That is the formula to calculate the VC. And basically, they equal 10 minus IC 64.5. RC 100 ohm. I change it to kilo ohm. 0.1. Okay. Okay. Oh. So you get 6.45.
Is that 6.64.5 times 0.1 kilo ohms?
Yeah. 100 ohm. The
The
thing is
60
the total in milliamp.
The 64.5 is milli.
6.45 on D6. If you want to multiply by 100, you have to divide by 1,000. The thing is, it's a milliamp, okay? And 100 ohm, you turn it into the kilo ohm. that they cancel out. Okay. Like I said, if you using the IC 64.5. Okay, let's see. That's a milliamp. Okay, time 100 ohm. So basically, milliamp. You have to change it to the amp. Okay. The thing 100 ohm here. Okay. If you turn it into the, let's see,
The
KO.
answer is 6.45.
Okay. 100 ohm, I turn it to kilo ohm. 0.5, 0.1. You divide 1,000. Okay. So basically, that will be a 10 to the power of 3. And milliamp, you have to change to the amp. 64.5 times 10 minus 3. So that's a plus 10 power of 3 minus 10 power of minus 3. They cancel out. Okay? That's why you get 6.45. The last one, VCE. VC minus VA. VC 6.45.
VE is 0. So that's
Right.
why it's 6.45.
That's a complete calculation. However, normally I'm not asking you to do calculations. Okay? However, you have to know the formula, basic formula. Okay?
Can I ask a question?
Yeah.
On the first equation that you did, -5 volts plus IB times RB plus 0.7 equals 0. How did you get the -5 volts? I
Okay.
don't
Hold
see
on.
it.
You want to draw the loop current. Okay? So this is the current will be flow this way. That means they going from positive, going. So we draw the loop current when they hit negative. That's why you get -5.
Okay. Also,
When you hit to the VRB, you understand it when the current goes to RB, this side will be positive, this side will be negative. So that's why you plug IB times RB. When you hit into the 0.7, positive here, negative here. So that's why plus 0.7, and that equals 0. Okay, that is the loop for the current. And from that one, you're able to calculate IB times RB. That means you want to keep this. -5 go to the other side. 0.7 go to the other side. -5 now will be 5. Plus 0.7 will be minus. That's why you get 4.3.
okay. And also on the beta, you're saying it equals 150. How did you get that? Am I saying that? Yeah, beta. 100. Oh, it's never
It's on the
mind.
right end, on the left-hand side.
Yeah, I see it now. Thank you.
Yeah.
I see it. Thank you.
If you're talking about beta, beta given. Right here. Also VBE given 0.7. That's what they said, diode voltage. Okay, the transistor without the DC power supply, they cannot work it. We will be using the transistor to make the amplifier. So the first basic, they need the DC power supply to make it work. But they're not doing anything with the amplifier. However, without the DC power supply, they cannot work it. Now, reason of the operation. Okay. First thing, they get what they call a cut-off, active, saturation. Basically, they get 3 modes working. What happens? Cut-off is in switching application. Okay, transistor can be cut off. Okay, that means they're not working. That is the base collector ammeter. And you know the current in here, IB. Current here, IC. Current leaving, IE. Okay, now cut off means no IB. Okay, then the transistor will be look like collector, ammeter, base. Transistor open. No current flow. They use for switching application. Okay, the next one, active. Use for linear amplification. That means the amplifier. Okay, active. And saturation. Also use for switching. Okay, so basically, like you get a switch, you can turn it on, or you can turn it off. Okay, but we will be working on active. That means how can we use it transistor to make for the amplifier. That means that we want to amplify your voice. Okay. Now, what they say here, cut off diode from B to ammeter is off. That means the diode here open. Okay. active diode from the base to emitter is on, and diode from the base to collector is off. One will be on, one will be reverse bias. That means off. And saturation, okay? Saturation, both diodes are on, and VCE equal 0. That's a basically definition for you. Okay? If we're talking about diode, transistor cut off, that means voltage from the base to the emitter is off. Okay? I give you example. If you get the transistor, that one, round, collector, emitter, and that will be the base. Okay, if the base VB equals 0 volts, so transistor is cut off or active or is saturation. If I given VB 0 volt, my question is, this transistor will be cut off or be active or be saturation?
It's based on the cutoff. The diode from B to E is off.
You understand me? The voltage here, 0.7
7.
volts. If we be higher than 0.7, so the diode here will be on. Now 0 volts, get me the diode at the emitter here, they will be off. So that's why they will be open. When they open, the current IB, IC, IE is 0. So that's why we're talking about cut off. Okay?
So what you just said, Mr. Pham, so you're saying that the diode from base to emitter is off and therefore there's no current flow?
Exactly. This off, that means they open.
Okay. Let me ask you another question too. You have two diodes in the transistor, one on the collector side, one on the emitter side. If
Right.
if both diodes, if one or both diodes are open, the transistor's not working?
That means they open, no current flow.
Okay. So, okay, I guess what I'm asking, do you have to have both diodes working for the transistor to work?
Okay, now I draw that one. So you can see that. Okay. And one go to, this is the base emitter. You get one diode. And another one go to the collector. You get another diode. So you get two diodes. So if I ground it here, I say VB 0 volt. And you know this diode will be off. That means this diode will be off. That means they open right here. And they open, that means the current IB, IE, IC equals 0. Okay? That's what they're talking about. They're using cut off for the switching. Okay? Now, if I get 5 volt here, $5, and I get 2 volt here. See what happened? 5 volt at the base. At middle, you get plus minus 0.7 volts. So the diode, this diode will be on. Okay? And if you get a 5 volt here, 2 volt on the collector, this diode also on. When a both diode on, they will be using the saturation. In here, they already telling you, diode from the base to emitter is on, and a diode from the base to collector is off, therefore active. However, now both on, saturation, both diodes are on. In this case, saturation, then the voltage VCE, that means from C to E, almost 0 volt.
Okay, thank you.
The thing is what, in order for guys to understand, you have to go through it again. Okay? Okay, this one, okay, I just quickly go over, okay? I already get solution for the transistor circuit. So what is VCE when V in equals 0? If you get a 0 here, who's telling me? If you get a 0 volt here, who can telling me what VCE? You know that will be C. That will be B. That will be E. They asking the VCE, that means here. If V in equals 0,
That means you don't have any base voltage, correct?
okay, now V in equals 0. The current IB will be 0, right?
Right.
The thing is the diode here will be off. For the diode on, that means VB have to be equal or greater than 0.7. However, 0, that means they will be off. Off,
So if you,
that's telling you the current IE equals 0. current IC. The thing is when they off, they open. Open here. Open here.
So that
The
means
question
that
is, what the V voltage from collector to emitter?
there is none. If it's open, you ain't gonna have no,
First thing you tell me what VC equals.
oh, I see what you're saying.
What VC equals.
That's from collector to ground.
Who knows?
It'll be VC is VCC minus ICRC.
Okay, the formula.
VCC minus O.
VCC minus, right?
Minus, not times. Minus ICRC.
What I see. What I see equals.
0.
Zero.
Zero. They open. They don't have any current. So telling me what VC equals.
It's equal to VCC.
VCC. That means equals 10 volts.
10 volt. From collector to ground.
When they want to, you want to measure VC, your meter high side connect to C, low side connect to the ground. And then you can get VCE. Basically VC minus VE connect to ground, 0. So that will be equal VC. They said right here, when V in 0, transistor is off. So that's why VCE equal VCC and equal 10 volts. That's why I try to explain to you how come you get VC equal 10. Okay? And they say, see the transistor, what the minimum value of IB is required to saturate it. See what they said here. Since the transistor is saturated, VCE equal 0. Then I see saturate equal VCC divide RC. And that you get 10 milliamp. Okay? The thing is what we already know. When the transistor saturate, VCE equal 0. We're just talking about that. Okay? Therefore, IB equal IC saturate divide to the beta. IC saturate 10 milliamp divide 200. The thing is the beta equal 200. That given to you 50 microamp. And they want to calculate the maximum value of RB when V in equal 5 volt. See what they said. When the transistor is on voltage across RB, AVRB. That means the voltage across RB, VRB, okay, will be equal V in minus VBE right here. That given you 4.3. Therefore, RB maximum will be equal to RB divided to IB. That given to you. The resistor here will be 86 kilo ohm. Okay, basically you can go through that, try to understand. Otherwise, next time I will be try to help you out. Okay, now this is a graph of IC versus VCE. This stands for VCE. This stands for current IC. Okay, and now you can see what is it here, what for? If you're looking into the graph, or what here?
IB.
That will be IB. Okay, if you get a point right here, what IB equal?
20,
You go to the right.
20 microamps.
That's what you get. If you get a point in here, what IB?
80 microamps.
80 microamp. They're telling you right here. Now, by the way, you here, what the VCE?
8.
Perfect. You're going down, 8 volt. Okay, if you want the current IC, this for IC, you go to the left. Okay, they will be higher than 10 milliamp. This is a relation between IB, okay, and the VCE and IC. So basically, the current here depends on IB. If you go into the point here, IB 40 microamp and the IC will be 6 milliamp. So this point will be get the IC higher than this point. So the transistor is controlled by the current. Okay, that's why they call a transistor either NPN or P and P transistor. That will be current controller.
So the bipolar transistor is current control.
Yeah, basically they begin the current IC depend on current IB. IB bigger, again IC is bigger. That is the current controller device. Current controller device.
Hey, Mr. Pham,
Yeah.
on this graph here, where's the mid-range the best place to operate? What areas are the mid-range?
Okay, I tell you. Now, you can see that in this area, we get 3 different areas. Part right here. That's what the cutoff. That means the transistor open. Next one in here. Saturation. Right here, you see that? The area in here is saturation. And the part in here, they call it active. Okay, let's see. When you want it to be a saturated, you want that just like the switching. Okay, they can be on, they can be off. Okay. Cut off means completely they will be off. However, what we want to using the transistor to build the amplifier. That's what active here. Okay, for amplify. So that will be half for designer. They want to design a transistor working at the amplifier. They can pick a one point here. They call a Q point. Okay. Why they want the Q in here? The point in here. When the point in here, you can get the curve voltage VCE. You can get the current IC. Okay. So make sure they have to be amplifier. They don't want amplifier to be saturated. You don't want amplifier to be cut off. So that's why normally they pick in the middle here. In the middle here, you know VCE, you know the IC, and you know the current IB. So you can design the amplifier by select the resistor. Okay, guarantee the point have to be here. You don't want the point in here. Why? The thing is, if you using this Q point right, this point, what happens is when the temperature going up, this point can be moved to the left, so the transistor can be saturated. That's what they don't want. Or you don't want to put the point in here. Okay? When the temperature changing, they can be go to the cutoff. Amplifier cannot be saturated and cannot be take off. Okay.
So
Cannot.
basically you're saying that the mid-range and active is the same thing. You want that nice sweet area where it's like basically in the middle.
In the big here, right?
Right. You want that medium range.
You want it in the middle.
Right.
The thing is, you don't want it go here. They can be saturated, or down here, they can be cut off. Amplifier cannot be cut off, cannot be saturated. They must be. Okay? Therefore, engineer, when they design, they need that. They pick the point here. Okay, they already get the IC, already get the VCE and IB, and now they have to pick up the resistor. Okay, RB, RC, RE to make sure they cannot be saturated, they cannot be cut off. However, to the guys, remember, transistor will be a current controller device. Why current controller? The thing is they depend on the IB. IB, you get IB, you can get IC, you can get VCE. Okay, so that's why they call a current controller. Later on, you're learning a JFET, field effect transistor. They will be a voltage controller device. Okay, why on the transistor current controller, you change the IB, you change the current IC output that controlled by IB. That's why they call current controller. Okay, so I'm sorry about today. I get a problem with the feedback. Okay, I will try to find out. The thing is, I spend a lot of time to try to fix my pencil, my pointer, make it working. This is the first time I run. I don't have any problem with those. And now I hit into the problem with the feedback. I have to spend more time to see why, how come I get the feedback. I'm really sorry
Mr.
about
Pham,
that.
Mr.
Okay.
Pham, you got the right input but the wrong output.
So, again, before we stop it, I try to telling you, the class now open 3:30 and will be end 8:30. I just meeting with the dean today. We come up with that. That's okay. No big deal. However, normally we will be open around little over 3 o'clock, maybe 3:10 or 3:15. Okay. This for the left. Okay. The first shift will be 3 to 6 o'clock. That means you coming into the first shift. Okay. At 6 o'clock, then basically you need to clean it up. Okay. That will be for the next student. If nobody coming in, then you keep working on that, no big deal. However, you will be limited to 2.5 hours. After that, you can stay in the program, do whatever you need to do, but not a level. Okay, we need to let the second shift people working on that. Or you don't want it, you can leave it. However, you have to get to on of the assignment, homework, or the quiz, okay? And try to make sure to study to understand. After you get through the program, I guarantee if you understand, that will be a very, very good for you to be a technician, or you want to going up to be engineer. That's not a problem. Okay. So anything else? Otherwise, will be
Hey,
good
Mr.
night,
Pham,
everyone.
Mr. Pham, don't forget to check the Excel for those errors.
Okay. Okay, good night.
Good night, Mr. Pham.
Good night.
Good night.